So welcome. My name is James Weaver, and I take it that you all are interested in music or are musicians yourselves. That's Davidu. Yes. Welcome and buongiorno. And I don't know. Does anybody not speak Italiano in the audience? Okay, so so that you guys can understand, I'm going to do this session in English. Is it okay with everybody if I do the session in English? Okay, very good. So this is called Getting Started with Counterpoint Composer. About me, can we shut the doors, please, so that we don't have noise? Shut doors, no noise. Okay. All right. So I've written several Java books. Java FX, Raspberry Pi books, Java Champion, Java 1 Rockstar speaker. I play well with others, and I've been speaking Italiano for many years. So I grew up taking music lessons, so I know what fermata means, and tremolo, tenuto, staccato, mezzo forte, crescendo, diminuendo, piano, pianissimo, pianissimo. Is that a word? Is that really a word? Okay. Segno, coda. So I've been speaking Italiano since I was a young child. And so what I'd like to talk to you about is counterpoint music. So counterpoint music is a special kind of music that was actually invented in Italy by a composer named Giovanni, let me cheat. Giovanni Palestrina in the 16th century, long time ago. But counterpoint is the relationship between voices, melodies, that are interdependent harmonically. So they must sound good together. But also, they're independent in rhythm and contour. And if you want to know more about counterpoint music, you can go to these links. And I'm going to show you how to find these slides. But here's a nice link on that. So here's an example of counterpoint music. You don't have to be able to see all the notes, but you'll notice that we have different rhythms on the notes. If you read music, we have different rhythms and also different contours. So they're independent, but they sound good together. Now, so listen to this. Notice that they had independent rhythms and contours, but the harmonies must be good together. By the way, I forgot, I need to take a selfie with all you nice people. So, here we go. So, smile. How do you say smile? Come si dice smile in Italiano? Huh? Sorriso. Sorrira. Okay, what she said. Okay, this one. Okay. Say cheese. Cheese. Very good. All right. So as I mentioned, in the 16th century, Giovanni Palestrina invented counterpoint. He invented a special style called Palestrina style. And he was a composer of sacred music, and he was best known as the 16th century representative of the Roman school of music composition. And he influenced then composers such as Bach and others, lots of others. Then in the 1700s, a gentleman by the name of Johann Joseph Fux, he took Palestrina's counterpoint style and he codified it. He made algorithms for that. He made rules for that so that he could teach students of music counterpoint music. And so he published something called Gradus ad Parnusum, which means steps to the gods or something like that. In 5 steps for being able to compose counterpoint music. And so his rules describe pitch and rhythmic relationships between notes. And so Johann, as well as Giovanni Palestrina, influenced musics of Haydn, Mozart, Beethoven, and countless others. So here is, I'm going to give you a little bit of a demonstration on the software that I've written to demonstrate some of the technologies that I develop with, such as Java and Spring and microservices and things like that. So I'm going to be showing you that software that I've developed, and I'll show you in context of a children's song. It's called Twinkle Twinkle Little Star, or Brilla Brilla una stellina. So I'm going to play it, actually. I'm going to play it on this. I brought a fun musical instrument. It's called a linstrument. And it's kind of a cross between a guitar and a keyboard. And so I'm going to play it here for you. First, I'm going to turn on the flute instrument. Let's see. Ah, wow. So you're all musicians, so you recognize that I made a mistake, right? Okay, let's try it again. Brilla, brilla una stellina su nel cielo piccolina. There we go. So just in case you don't applause, I brought my own applause here. And laughter. If you don't laugh at my jokes, I brought my own laughter here. And if I need more laughter, So that kind of makes you laugh, doesn't it? Oh my. Okay. Well, anyway. So now what I'd like to do. So this is a demo.
This is Jim Weaver, and I'm going to demonstrate
how you can use Counterpoint. If you miss me, like later, if you want to hear my voice again and hear me demonstrate this thing to you again, just go to the slides and play here. And I'll talk to you some more and tell you all about what I just told you, okay? But I'm going to since I'm here today, I'm going to go ahead and demonstrate it to you live. So all you need to do is go to counterpointcomposer.com. You just type in counterpointcomposer.com. And actually, if you have an internet connection, you can follow along with me, even on an iPad. And this application will come up. It's running in Pivotal Cloud Foundry. Cloud Foundry is an open source package for hosting cloud applications, written in various languages such as Java and Go or Python, things like that. I'm using Java, and we're using technologies from Pivotal called Spring Boot, which is open source, and of course Cloud Foundry. So we go to Counterpoint Composer, and I'll just do a simple thing, the Brilla Brilla una stellina. And so we go there, and I'll click in here and click the keyboard. And I'm going to go through the software first, and then I'll go through the technical details. So first the software and the musical stuff, then the technical stuff. So I'm going to go ahead and create this. I'm holding the Shift key down to create this first chord. Brilla, brilla una stellina. Okay, let's see. So I typed in that, and I'm hitting compose. And so now it sent the initial chord and the melody that I just created into the cloud using web services, microservices, and with JSON up and JSON back, and the JSON coming back then, it composed the counter melody that you see here. and then brought it back with JSON, and now we're displaying it. So now I can go ahead and play it. I'm going to mute this and make it go faster here. Whoops. Let's speed it up here. Okay. So in the cloud, then, this counter melody here was created with a Java program that uses Johann Joseph Fux's rules, which then were based upon Giovanni Palestrina. Okay, so also you'll notice that it's pretty small here, but you'll notice some symbols here. Those were also computed in the cloud. So when there are chords that are made up by these counter melodies, then it computes what chords those are, and then we display that. Again, I'll give you all the technical details. Nothing is selected. Okay, so I'll go back to the slides. So here's, for review, the steps for the demo. You can look at the slides and review those steps. But I clicked in the software. I clicked the clear button to clear everything out, and then I made sure that we're selected first species and Ionian mode for a very simple case. Then I clicked here, I clicked the keyboard, I punched in the melody, and then I hit compose. So those rules, or those steps, are all right here if you need to know them again. And so to learn more about first species counterpoint, remember there's 5 species, 5 steps. You could either go to the Wikipedia article, which is, there's a link here. These slides are online. Or you could go to this article in Open Music Theory about composing a first species counterpoint. And also, there's an article about composing a cantus firmus. Is that Latin? I think it's Latin, cantus firmus, but it means main melody in Latin, and maybe in Italian, I don't know. Anyway, so we have the second species counterpoint. First species counterpoint is note on note. It was whole note, whole note. Second species is the cantus firmus is whole notes, and the melody, or the melodies, are half notes. So 2 for every one. And so I'm going to go ahead and go to Counterpoint Composer, select second species. Oh, I got to type that in. Sorry, I shouldn't have erased it. Okay, so here we go again. Get to see these steps. Okay, now we'll compose. I've got second species there. So this is what it sounds like. Then I'm going to start to play, and then I'll speed it up here. Okay, here we go. Okay, so far, Giovanni Palestrina and Johann Joseph Fux's rules are working out pretty well. So now we'll go to third species counterpoint. We'll compose. Now, third species is whole notes in the cantus firmus and quarter notes in the counter melodies. And so we've just selected 2 melodies here, or 2 melodies altogether. But we'll go ahead and play this. Again, I'm going to slow it down here, or speed it up. Okay, here we go. Okay, so that's third species. And then fourth species is, I'll go to the slides here. It explains it, so you can. It explains and then it demos it. But fourth species then is sustained half notes. So you have a lot of suspended kind of intervals. And so I'll go ahead and demonstrate that by clicking fourth species and hitting compose. Now, one thing I haven't implemented is the ties. So, but imagine that there's a tie here and a tie here, you know, between those notes. So I'm going to start it over here for you. So Giovanni and Johann were just geniuses as far as, like, you know, so how many centuries ago that they were creating algorithms for this kind of thing. I'm very fortunate that they did that, so that and they must have been looking forward centuries to where computers could then take their work and algorithmically compose counterpoint music. So it must have been very exciting for them to even think about that kind of thing. And then fifth species counterpoint is everything combined, all the four species combined plus rests. So here's an example of fifth species, and I'll go ahead and click fifth species, compose. It's a very florid kind of counterpoint. And we'll go ahead and start this, and again, I'm going to speed it up. Ignore that. Okay, here we go. Okay, so those are the 5 species of counterpoint. And then a couple of other features of this software. And if you're familiar with music composition, you know about musical modes. So there are things like Ionian mode, which the scale starts from C to C. Dorian goes from D to D. And so here's an example of composing in a different mode. I'm going to compose something in Dorian mode. So I'm going to clear this and select Dorian mode. I'll go ahead and maybe click second species, maybe first species, I don't know. And go ahead and type something in here. Okay, we'll compose. And this is in Dorian mode, so it has a little bit of an eerie feeling. A little bit of a minor kind of eerie feeling. So then another feature of the software, besides doing all these modes, then, is the ability to change the rules. So you can switch off individually those 70 plus rules that Palestrina and Fux created. So in the software, we can click rules, and these are the rules that they created. And so let's say that I want to switch off one of the rules named where we need to avoid unisons in 2-part counterpoint. So we're not going to have the same note in 2 counter melodies when there's 2 parts in the counterpoint. So I'm going to switch that one off. And so if you look at what we have here, it's always an intervals other than unison. But I'm switching off that rule, and I'm going to hit compose again. And I want you to look over here. It's going to allow this to be unison, and also this line, the computed line then will change because that rule was relaxed. So I'll go ahead and hit compose. Notice that changed, and I'll go ahead and play it. I'm going to speed it up for you. Okay, here we go. allowed the unison at the end. So there are 70 plus rules, as I've mentioned, and you can, at your leisure, you can scroll through them and notice all sorts of technical rules that Palestrina and Fux came up with. So that was the kind of the musical counterpoint part of this. What I'd like to do now is go to the technical portion of the presentation. So if I go to Counterpoint Composer, both of these slide decks are here. If I go to Help, what I just showed you is in the Getting Started. What I'd like to show you now is the technical presentation, and that's what if you click this, the technical presentation will come up, which is this one right here, from a technical perspective. So first of all, the high-level architecture for this application is a one-page HTML5 application, and then we have lots of microservices in the cloud, in the Cloud Foundry, hosted in Cloud Foundry, as well as hosted by NoteFlight. NoteFlight it's a music notation software that's hosted in the cloud, and so we are embedding the NoteFlight UI, user interface, in our application, and then we're making use of some services. One service computes the counterpoint. It takes the initial chord that we typed in, as well as the cantus firmus, and it takes that as input, and then it outputs in music XML the composition based upon what species we wanted, 1 through 5, what mode we wanted, and of course the cantus firmus and initial chord. Also, I'll be demonstrating soon this chord analyzer service. But these chords that come up, every time there's two different notes simultaneously hit, it calls the chord analyzer service, sending it a JSON stream that represents those notes, and then it computes the chord and returns the name of the chord. So that's the high-level architecture. So the source code is in GitHub if you want to see it. These slides are online, so all you have to do is click that link to get to it. The source code for Counterpoint service is here, and the Chord Analyzer client and service are here. And I've already told you that these slides are online. So this kind of deals with a little bit of technical detail. I'm gonna blow this up a little bit for you. REST services. Here's the initial chord and main melody. It does a post of those things using a JSON string into this endpoint that I've got in the cloud in Cloud Foundry. It returns music XML, which represents this staff music in all the parts that I wanted. And then every time there's notes together, it calls. I meant to do that. There's a step there, by the way. Be careful. Okay, it calls a chord analyzer service, this /analyze, and then returns the name of the note. Okay, and that way we put it there. Okay. So we'll examine the chord analyzer service. Now we'll get into a little code. So we use Spring. So we annotate Java applications with Spring to help us be able to create REST services very quickly. And so here is an example of the REST service that we've created. There's the endpoint. So it's counterpointcomposer.com/analyze, and then with parameters of the notes that we want to find out what the chord is. So as a matter of fact, if you just, from a browser or from curl, if you just entered, Counterpoint Composer, Counterpoint, I'll give you the URL, but chord analyzer service /analyze, and then put some notes in there, it would return what the chord is. So here we've got a REST controller, And we're saying that this is going to be a REST controller. And then we are saying what the endpoint is, analyze. And then we're mapping that to a Java method. And then here with the REST request param annotation, we're telling it what the parameter name will be. It's notes, and it takes a string. And then we're going to go ahead and do the computations that's based upon the JFugue Java library. And then we're going to return music chord. And since Jackson 2 is on the class path, Spring's mapping Jackson to HTTP message converter is automatically chosen then to convert the music chord, which is a Java POJO, into JSON. And if you want to learn more about that, you could click here on building a RESTful web service client. So then here is music chord. It's a Java class that represents a chord. So here are the member variables and the instance variables and then methods for this POJO. And that's all you have to do. And then it automatically serializes and deserializes that. So it's very easy to stand up a REST controller in Spring. And then to make the application executable for Spring, then we just annotate this with Spring Boot application. And then here's our Chord Analyzer service application. We have a main method, and then we say Spring application.run, and then we pass in the name of our application. And then if you want to know more about that, just click Building a RESTful Web Service Spring Guide. Now, to deploy this, it's very, the development deploy cycle is very easy with Spring and Cloud Foundry. I just do a Maven clean install, which compiles everything and builds the jar. I just use one jar file. Everything is in one jar file, deployed independently in one unit into the cloud. And then to push it into the cloud, we just use CF, which stands for Cloud Foundry, CF push, and then a parameter, and then give it the jar and tell it what name we want it to be. And it's as simple as that. So it's kind of an easy button to get your jar file, which has your web services, into the cloud. It's extremely easy to create a REST service and put it into the cloud. This is the Pivotal Web Services console, where once it's in the cloud, then you can monitor it, you can scale it up. Maybe you have more users, so you want more instances of your services. So you can certainly do that. You can monitor them, check for their health, things like that. And then if you want to create a Spring application, the best place to go is to start.spring.io, and you give it some information about, are you going to make REST services? Is it going to be a web application? And then you just select those things. So that's it. Now I'd like to show you Chord Analyzer Client. And here we have in the cloud the Counterpoint service. I'm going to focus here on the Chord Analyzer service. I've already kind of showed you the code behind it, but I'll demonstrate it for you now. The idea is that we have some MIDI keyboard, and then we have an application in the cloud, or a REST service that computes the chords. And then we have this UI that I'll show you now that then that we can use then to do that. So I'll go ahead and go to just a Chrome window here, and then here is Chord Analyzer service. All I have to do is put that up there, and I think I've already plugged in my MIDI keyboard. I better select the right thing though. We'll select grand piano. So let's see. So notice that I'm doing chords. Notice that it so it will tell you what the chords are. When I'm punching it in, it's using web MIDI interface that's running in in Chrome, and then it's sending it up to the cloud, analyzing the chord, and then coming back. So it's pretty quick. So I'm going to play you a little song here to close things up here, and then you'll be able to see the notes and the chords. This is a Prelude in C by Bach. I'll promise. I'll try to make a few mistakes just to show that I'm human here. Thank you for your attention.